Hi everyone, welcome to again. We're still doing Limpopo provisional control test 2022. It sounds weird when I'm saying like that. It's 2022, 2022. That's so weird. For grade 12, okay. Yeah. So check out our previous videos. We've done already. We've done question one. Question one is about quadratic sequence. You've done that. You've done arithmetic sequence. Question two, you've done question three, which is a geometric sequence. Check out our previous video. Now let's do question four. Question four. Question four. Where's question four? Question four. It's about Tan-Chord theorem. We are required to prove the Tan-Chord theorem in this video. I'll be showing you how to prove a Tan-Chord theorem. This is a question that you get in your Euclidean geometry. So this is Euclidean geometry, one of the interesting questions you can get. So yeah, so let's go. Question 4.1 in the figure below. So this figure here, they tell us that O is the center of the circle. So O is the center of the circle PQR on the circumference. So PQR, the point on the circumference, and SR is a line, is a tangent to the circle center O at R. Okay, so we're told this is a tangent, and we're told this the triangle here, they are having points on the circumference. Great. And then they're telling us that prove that angle PRS. So when you have this symbol over there in between like this, they're telling us that the way you read this, you say angle PRS. That's how you read it. Angle PRS. So meaning angle PRS. So they're talking about this angle. So this angle, so prove that this angle is equal to angle Q. This is angle Q. So prove that this angle and this angle are equal. And that's a Tan-Chord theorem. Tan-Chord theorem says if you have a circle, if you have a circle, and then you have a tangent, right? And then in that tangent you have triangle, right? So an angle that's between a chord, and the tangent. So this angle here is equal to this angle, right? Even this angle here is equal to that angle. That's what the Tan-Chord theorem says. This angle is equal to that angle, or this angle is equal to that angle. That's the Tan-Chord theorem. Tan, tangent, and the chord. This angle is equal to the angle, or this angle is equal to that angle. So in this case, you're looking at this angle, so this angle is equal to that angle. Tan-Chord theorem. Alright, so let's do that. So how do you do this? First thing first, what I see here, when I see a chord, right, I realize, damn, remember a chord and a radius, chord and the radius, the relationship between a chord and a radius, an angle between a chord and the radius is 90 degrees. Chord and the radius are perpendicular to each other. So not a chord, sorry. A tangent is perpendicular to the radius. Always. An angle between the radius and the tangent is 90 degrees. Tangent is perpendicular to the radius. This is the information you need to remember. I'll say it again. A tangent is perpendicular to the radius. A tangent, it's always going to be perpendicular to the radius. So meaning, if I write my radius here, right, and let me just make a straight line. So if I write my radius OR, so meaning then the sum of this angle and this angle should be equal to 90 degrees. Why? Because the tangent is perpendicular to the radius, right? So we are saying, let me just write that down. We're saying this angle here, ORP, angle O, make it smaller, angle ORP plus, so this angle plus this angle, angle PRS angle PRS should be equal to 90 degrees. Why? Because the tangent is perpendicular to the radius. The tangent is perpendicular to the radius. Okay, so from here then we can say, okay, cool, because we're looking for PRS, the angle PRS, so we can just make PRS subject to the formula. Angle PRS is equal to 90 degrees minus, so you're taking this to the right hand side, tend to be minus angle RORP, right? So that's first equation. Angle PRS is equal to 90 degrees minus angle ORP. Great. So that's the first thing you discover. These two are in 90 degrees. Another thing in mind, it comes in my mind, is these two, let me make a different color. These two sides are equal, right? Why is that? Because they are both radius. They are both radii. They are radius. So they are equal because the OP is a radius, OR is a radius, right? And then this reminds me of one of the triangle theorems that you need to know from grade 8, grade 9, that says if these two angle sides are equal, therefore the base angles are equal, right? If two sides are equal, therefore the base angles are equal, right? Or one may say if angles opposites, so angles opposites are equal, so angle opposite equal sides are equal, right? Angles that are opposite equal sides, those angles are equal, right? That's basically what we see here. So since we discovered that this and this are the same, let's write that down. It's very important to write that. Everything that you see, write it down, right? So let's say this is the first point. So the second point that you see is angle, the side OR is equal to the side OP. What's the reason? They're both radius. We can just say radii, which is the period of radius, right? And then the third thing what you're seeing it now is this side, this angle and this angle are equal. What's the reason? It's because of this. This is the reason. The reason is opposites, or angles that are how do you say this? Angles opposite equal sides are equal. So angles that are opposite to equal sides are equal. Okay, so we are saying angle, we can write it down, angle OPR, right? That angle OPR is equal to angle ORP. Those angles are equal. Why? Because angles opposite equal sides are equal. Angle opposite equal sides are equal, right? That's the reason. Okay, fourth thing to recognize is, well, we have a triangle. Now if you have a triangle, we know this, that the sum of the triangles, some of the interior angles are supplementary. Interior angles are supplementary. So meaning the sum of the interior angles are equal to 180. So interior angles are always supplementary, meaning the sum of the angles in a triangle are equal to 180 degrees. So this angle plus this angle plus this angle should give you 180 degrees. So let's write that down. Angle POR, angle POR, right, plus angle OPR plus angle ORP are supplementary. What's the reason? interior angles of triangle are supplementary. Interior angles of a triangle are supplementary. Okay, and then from here, what do we know? We know that this and this, these are same angles, right? OPR and ORP, same thing, same WhatsApp group, right? So OPR plus ORP can give you twice of ORP. We're going to just keep it ORP because we want to trace it back to this angle. So we can say then if you add angle OPR plus angle ORP, it should give you 2 ORP, right? Because these two angles are the same. Maybe I should have write it this way. This is angle OPR is equal to ORP. Okay, and then so ORP is twice ORP. ORP, angle ORP plus angle ORP is equal to 2RP. See that? So that's basically what we're gonna write down. Don't have to write this step. So it'll be 2 angle ORP. Okay, so that's what we have. And then so from here we can now just take, so we've got POR. What's POR? POR is this angle here. Hey, what is the relationship between these two angles? Remember, the angle at the center is twice the angle at the circumference. Okay, let me remind you of that theorem. So you have a circle, make it bigger, you have a circle, and then if you are told this is a center, right, and we have this angle here, I mean, it can be subtended by a chord, an arc, or it can be subtended by a chord, doesn't matter. And then also you're told you have this over here. Okay, so the theorem says the angle at the center is twice the angle at the circumference. The angle at the center is twice the angle circumference. Meaning, if this was x, let me make it smaller. If this was x, therefore this would be 2x. The angle at the center is twice the angle circumference. So you see already that you have this and you have this. They're all from the same point. It's either subtended by the chord or the subtended by the either subtended by an arc or subtended by a chord, right? They're both from the same point. Okay, they're both from the same point, meaning then for this angle is twice this angle. Okay, so meaning angle, let's write that down. Angle, which angle is this? Angle POR. Angle POR is twice angle Q. What's the reason? Angle at the center is twice an angle at the circumference. Angle at the center is twice the angle at the circumference. Okay, we're doing something, we're going somewhere. So do we see something here? Do you see a relationship? So this angle, let's call it equation 2, let's call it equation 3. Now do you see this relationship between equation 2 and 3, right? So we can just substitute this with 2q. You're gonna have 2q plus 2orp is equal to 180 degrees. Okay, if we want, we can now divide by 2 throughout, because we are looking for q, right? This is what you're looking for, q. Wants to see what q is equal to. Basically, we want to prove that q is equal to this as well. If q is equal to this, therefore q is equal to angle PRS. So let's now remove that 2. So you're going to end up with angle q plus angle ORP is equal to 180 divided by 2 is 90 degrees. Okay, so then you can now take ORP to the right hand side, you can already see it. Angle Q is equal to 90 degrees minus ORP. See, angle, this equation here, this is equal to 4. Equation 4 is equal to equation 1. So equation 4 is equal to equation 1. Therefore, angle Q is equal to angle PRS. And that's exactly what they want us to prove. Boom. That's a Tan-Chord theorem. This is how you prove a Tan-Chord theorem. So this is exciting. So we've learned a couple of theorems in Euclidean geometry without really giving you the everything. But I've given you what you need to know to prove this particular problem. And this problem is almost always gonna come. They're always gonna test your Tan-Chord theorem knowledge, right? What you need to remember, number one, you need to remember that a tangent is always perpendicular to the radius. You need to remember that. And you need to remember that lines from a line from a center to the circumference is always a radius. So those lines are always going to be equal. Even this one is a line from a center to the point. These lines are always going to be equal. So radius. And what you need to also remember is angles opposite equal sides are equal. So you have a triangle and you're told that this side and this side are equal. You should always know this base angles should be equal. All right. And another thing is interior angles are supplementary. So meaning the sum of the angles is equal to 180. Something which we know. And another thing is angle at the center is twice the angle at the circumference. So if you have a situation like this, so you should know that angle at the center is twice the angle of the circumference. And also, yeah, so that's basically what you're trying to prove. You're trying to prove that this is equal to that, or this is equal to that. That's a Tan-Chord theorem, and that's how you do it. And from there, everything will fall together to give you this beautiful answer that you see, that Q is equal to 90 minus angle ORP, and angle PRS is equal to 90 minus the angle ORP. Therefore, these two angles are equal. Boom, that's your answer. And this is how you answer this question 4. Awesome.